So everyone will get a little permission request for that. So, thank you. And we'll give it well, it's actually a minute after. So why don't we go ahead and start, and then people can just come in even once we have started the program. So I'm Paula Mueller. I chair the Queen Anne Community Council, and we have this evening two people with us. Bill Fay. Bill is a member of our Community Council Public Safety Committee, and one of the aspects of the committee is to handle emergency preparedness issues. So Bill is our community emergency communications hub captain for Queen Anne. And I'm going to turn it over to Bill to introduce our guest speaker this evening. And thank you all for being here.
Yes, welcome. As part of the Public Safety Committee, I also work with other people in Magnolia and Inner Bay in educating people in how to become better at disaster preparedness. And that's sort of the purpose behind this public safety presentation involving our guest. If you don't know, there are these communication hubs. They are sort of locations in both, actually all over the city, but specifically here in Queen Anne by the community center, that in the case of a major disaster, this communication hub will be set up, and there'll be all kinds of information there and places for you to come and share your information and share resources and find out more about what's happening. Because in the case of a major emergency, major communication channels and everything will be shut down. So I'm the hub captain, so I'll be the one sort of running that. Of course, we always encourage people to take care of you and your family first, and then check out your neighborhood. And then you can come up to the hub, Queen Anne Hub, and learn more and offer more and help out the entire community. So, but instead of just what we would do after the disaster, there's a lot you can do before. And of course, we have all kinds of materials about having the proper water and food and everything else in storage to withstand up to 2 weeks in the case of a major disaster. But then there's also things that you can do specifically about retrofitting your home. And that's what we have tonight. It's a presentation by Leif, who will explain to us sort of what seismic retrofitting is all about and how it relates to earthquakes and being prepared for the next big one. So take it away, Leif.
Thank you very much, Bill and Paula, and thank you all for showing up to learn and help yourself get motivated to become a little bit more prepared. As Bill mentioned, I'm going to talk about earthquake retrofitting. I'm going to share my screen here. And a little bit about myself. The reason I know what I'm talking about, I hope, is that I've been running a company called Seismic. We do earthquake retrofitting. That's bolting single family homes and some other types of wood frame structures to their foundations and keeping them safer in the event of an earthquake. This doesn't want to advance for me. There we go. A little bit about myself. I am a Queen Anne resident. I have been off and on, mostly on, since 1991. Raised a family here. Had to choose between Co and Hay for my kids, but right when we were choosing, the brand new Co building burned down. And so we became a Hay family, and then a McClure family, and a Ballard High School family. And I was on the board of the Queen Anne Little League. And so I am literally your neighborhood retrofit contractor. I've been, specializing in retrofitting Seattle homes for the last 24 years now. And I wanted to talk about sort of my angle on disaster preparedness, mostly focusing on retrofitting, but also why retrofitting matters as much as I think it does. So we're going to talk about, preparing for disasters in general. And then, of course, we know that earthquakes are one of the biggest disasters that we need to be prepared for here in the Seattle area. We're going to talk about how our, 100-year-old wood-framed homes perform well and how they don't, and what we can do about that. And I do have a list of, kind of answers to frequently asked questions at the end, but if you have questions, I'm going to ask, I don't always have visibility of the chat. So rather than putting questions in chat, go ahead and unmute yourself. I hope you're able to do that and just chime in. Or if somebody else is does have an eyeball on the chat, Paula or Bill, and you guys can let me know that there's a question, I'll do that. And then please don't be offended if you have a question and I say that's pretty specific, I may ask to have a conversation with you separately after the fact, because it may not apply to too many people.
Leif, I'm going to interrupt you for just a minute. Somebody had a problem losing videos, or I'm sorry, audio. Has that been resolved, or is everybody able to hear Leif? Can somebody let me know if you can hear him? Okay.
I'm okay with sound.
Okay, yeah, it sounds like everybody else is able to hear, so we're good. I'll monitor chat, and then also if somebody has a question, feel free to use the raise your hand option, and I'll let Leif know that you're waiting.
Great, thanks, Paula. And
Thanks.
I see Brian commented, I do have visibility on chat right now, and Brian says he's good to go. So
Yeah, okay.
I hope, Sean, you can figure that out. I'd like you to be able to hear us. All right, so to talk about why we should be prepared, I actually want to talk about Hurricane Katrina a little bit. Totally different kind of disaster than we get here. Of course, we don't get hurricanes, but I think a lot of the effects are the same. And in fact, hurricanes, you often have the advantage of at least a few days' notice. Earthquakes come out of nowhere. We get zero notice, really. We know that we're due, but we could be due for 10 years, and it's easy to get nonchalant because who knows when it's actually going to occur. But in New Orleans in Hurricane Katrina, just like there will be here, the infrastructure was and will be severely damaged, and that's going to affect life as we know it in so many ways. Transportation, communication. Bill can probably talk a lot more about how having a radio network is helpful. Even without that, knowing that cell phones and long distance may be more resilient. That's why it's helpful to have a plan for if you're trying to communicate with someone locally, you both call someone, Uncle Joe in Milwaukee, and he can relay the information from you. And then utilities will be out, water, power, gas. So the things that we are used to relying on a day-to-day basis, we won't be able to. As far as rescue, the same things that are affecting us, as far as the roads being passable and airports being down, of course, that will affect rescuers as well. So expecting rescue or even emergency supplies to get parachuted in the next day is unrealistic. Bill talked about having 2 weeks of supplies. I think that's a good minimum. Things will not be back to normal after 2 weeks, but perhaps we'll have a better, more coordinated emergency response by then. And then, of course, I'm talking about retrofitting homes and helping to keep them intact in an earthquake. So if your home is not livable after an earthquake, where will you shelter? In Hurricane Katrina, it was the New Orleans Superdome, which was overcrowded. There were talks of, assaults and rapes occurring. The toilets were not working. There was garbage piled up. It sounded like a pretty miserable place to be. So I would say that if you have any control over your likelihood of being in your own home versus shelter, let's do everything you can to spend time in your own home. And then, keep in mind that it's not just you. If you protect yourself, you will be better able to respond to, friends, family, neighbors. If you have rental property, make sure that your tenants are whole. It makes you a more useful human being if you're not just trying to fend for your own survival. So again, we don't get hurricanes. We do get a variety of natural disasters. Snowstorms, windstorms can be, it can affect us quite a bit, but really what affects us, what's going to cause the greatest, impact on our day-to-day life will be an earthquake. And I think the folks in California have the advantage, if you want to call it that, of being very aware that they're in a high hazard zone. The folks in the Bay Area in Southern California, those are just known earthquake areas. Seattle, not quite so much, but you look at this hazard map from USGS, and we are, one shade of red lower than the Bay Area in Southern California. We do get disastrous earthquakes. We do get destructive earthquakes, even though we haven't had them in the last, 100 and some years that we've been building homes like we have now, like we live in. And, why do we have all those earthquakes? It's, I think we all understand it's because of plate tectonics. In the middle of the Pacific, there are a couple of plates, new earth being formed out of magma and the plates spreading. So underneath the Eastern Pacific is the Juan de Fuca plate moving our way and riding under the North American plate. And it doesn't just move smoothly. It moves in fits and starts. It kind of grips and causes some pressure and friction to build up and then lets loose all at once. And it can let loose in 3 different ways. And that causes 3 different kinds of earthquakes. And the one that we've experienced a few of would be a deep slab event. And that occurs, if you can see my cursor here, my mouse, sort of underneath the crust of the earth, but not necessarily right where the plates are riding together. It has to do with cracking of the North American plate and just sort of a release of pressure there. And what we think of as the big earthquakes that we've experienced are really not big in the grand scheme of things. We get 2 other types of earthquakes that are going to be much more destructive. I think everybody understands, has heard the term the Cascadia subduction zone, and that's when pressure is released all at once right along this the actual fault where the plates come together. That will produce a huge earthquake. At magnitude 8 if it's in one location on the plate, magnitude 9 if the whole fault zone sort of unzips one section after another. And that's, for those of us that experienced Nisqually in 2001, 22 years ago, every order of magnitude is 10 times more energy. So a magnitude 7.8 is 10 times bigger than what we saw. A magnitude 8.8 is 100 times bigger. So a tremendous big step up every order of magnitude. And then actually the one that I worry more about is the Seattle fault zone, one of these crustal fault zones that's very, very close to the surface. Won't produce a large magnitude earthquake, but will produce a very violent earthquake. We're going to come back to some of these numbers. On the left here, there's information from CREW, that's this Cascadia Region Earthquake Workshop, bunch of disaster preparedness, emergency management professionals and geologists, got together to use science to figure out what will things really look like after a Seattle fault zone earthquake, and the structural damage will be severe. So we're going to talk about these 3 different types of earthquakes, sort of in order of how frequently they occur, which is also how the same order of, sort of least to most worrisome, least to most destructive. So we've all, a lot of us were here for Nisqually in 2001. And occasionally I get homeowners who tell me, my home has been through 3 big earthquakes, so I probably don't need retrofitting. And I try to gently correct them and let them know that their home has been through 3 moderate earthquakes. There was they're right that there was one in 49 and one in 1965, and then Nisqually in 2001, and those were all a little bit less than a magnitude 7. And our homes survived them almost 100%. And that's great, because that's sort of the frequency that we can expect, and the severity that we can expect. And this photo here is from Nisqually. I think these are homes in West Seattle. And you can see, while they're brick veneer, these are wood framed homes, just like most of our Queen Anne homes. And really all the damage is that the chimneys failed. So I think we got very lucky. We should not be nonchalant just because we've survived that type of earthquake, though. So the second most frequent, the second most worrisome would be the subduction zone earthquake. This one, a lot of people are surprised that I don't mention this third, that this isn't, the one that I'm more worried about, because it is the big one. It really is. But as I mentioned, a magnitude 9 occurs when, the entire fault zone sort of unzips one section at a time up or down the coast. And so all the energy is not released, all at once from one location. It's sort of incremental. The duration is going to be incredible. Nisqually shook for 30 or 40 seconds, and this will shake for, this says 1 to 3 minutes. I've heard 3 to 5 minutes on the larger earthquakes. So it will be immense. And, we could take some comfort in knowing that where the pressure is building up is off the coast, but actually UW geologists have said that line B here, this red line, is more where the epicenter is likely to be for a subduction zone earthquake right off the Washington coast. It's actually going to shake underneath the Olympic Peninsula, and 50 miles instead of 100 miles from us. So that will definitely affect how violent the earth shakes. There are a lot of things that affect the ground motion in an earthquake, and certainly magnitude is one of them, but also distance, depth, duration, the frequency of the shaking, all of those. So, one good example of this type of earthquake is the Fukushima earthquake in 2011. A lot of us may remember the nuclear meltdown, because there was a tsunami that actually flooded the nuclear plant and disabled the cooling facilities on that. And the tsunami itself killed tens of thousands of people. We will have a tsunami with this kind of earthquake, and it will not just be a coastal tsunami. It will come into Puget Sound. We will even have tsunamis in some of our lakes. This earthquake, the Cascadia subduction zone event, got a lot of press in 2015, 2016, when the New Yorker published an article, and it won a Pulitzer Prize because it had great science behind it. But it was also a little overdone, and some of you may recall some of the sort of overly dramatic language in it. But it was really, really effective at motivating people through fear to act and become more prepared. And so I did send Catherine Schultz, the author, a thank you note for helping Seattle in the Northwest just raise the awareness here and help us get motivated to become prepared. And this, this first quote here talks about the effect on infrastructure, power, water, sewer, 6 months before highways are back functional again. And you don't even think about it, 18 months before hospitals are going to be really back to where they ought to be. And then, so there was another quote about everything west of I-5 will be toast, which was a little silly, but one of those quotes that everybody repeated. And I actually had one homeowner who called me. She said, I either need to retrofit my house here on Finney Ridge, or I need to move to the University District so I can be on the correct side of I-5. And I had to tell her that's not really how it works, but yeah, let's take care of your house. But I love this quote, and I know y'all can read, but I'm just going to go over it because I love it. In theory, Catherine said, in theory, those who are at home when this is hit should be safest because it is easy and relatively inexpensive to seismically safeguard a private dwelling. But lulled into nonchalance by their benign environment, seemingly benign environment, most people in the Northwest have done so. And houses that are not bolted foundations will slide off, or rather, they will stay put, obeying inertia, while the foundations, together with the rest of the Northwest, jolt westward. And I'm going to come back to two things: the nonchalance and the houses obeying inertia and the ground jolting westward. So remember those two things. So that was the subduction zone, the Cascadia event. Then the crustal event. The picture on the right shows all the fault zones in the Puget Sound Basin. There's the South Whidbey, the Seattle Fault Zone, the Tacoma Fault Zone. And one of these lets loose every 300 years or so. And the Seattle Fault Zone specifically, every 1,000 years or so, we get a big earthquake. And the last one was 1,100 years ago. Oh, I forgot to mention with the Cascadia event previously, we get those every 200 to 500 years. And the last one was now 323 years ago. I don't know that I have the time to talk about how we know exactly when that was, but it's kind of interesting. This one, the geological evidence of this last Seattle Fault Zone earthquake, roughly 930 AD, is incredible. There are forested hillsides that the earthquake caused landslides, and these entire hillsides slid into Lake Washington and Lake Sammamish. And today, those 100-foot Doug fir trees are still standing at the bottom of the lake. And if you go over those with a boat with a fish finder, you can see them. There are forests in the bottom of our lakes because of earthquakes. So those people that tell me my house has been through 3 big earthquakes, let's rethink what a big earthquake is. So an example of this type of event is in Christchurch, New Zealand. About a month before the big Japanese earthquake, there was a shallow crustal earthquake in New Zealand, and it killed a bunch of people. But what's striking to me is the magnitude was only a 6.3. Right? People think a magnitude 8 or a 9 is what you need to worry about. No, that 6.3, a small earthquake, if it's shallow, can be very destructive too. And the short duration also strikes me, because whatever energy was in that earthquake was released all at once, which made it very violent, rather than being released over several minutes. Here's that crew Cascadia region workshop report. They talk about, we will have deaths that number in the thousands, and a lot of injuries. They talk about the infrastructure damage, but then the buildings. 10,000 buildings or so will be destroyed. 46,000 will be red tagged, they estimate, and over 150,000 will be yellow tagged, and you'll be, unable to use them as they are designed to be used. So that's pretty striking. The effect on buildings, and that's something that we can totally control. We have the technology to prevent that kind of damage. So, regarding our homes, and on Queen Anne, we have a lot of homes that were built, between 1900 and 1940. And I guess the bad news is that building code didn't require anchor bolts until 1965. Plywood wasn't really used until after that. And so most of our homes were built without earthquakes in mind. The building code just didn't think about them. The good news is that even though that's true, our wood framed homes perform pretty well in most ways. Single family wood framed homes perform, they're one of the two best performing types of buildings. The other one are skyscrapers, which of course are engineered to resist the forces and have things like, vibration dampening systems and counterbalances and all these things to just, take care of all those forces. We don't have that. It's just kind of dumb luck that the nature of wood construction and nailed wood to wood connections is kind of this lucky combination of strong and a little bit flexible. And it works in most ways. In most ways, I say, the lowest level of the home where the force aggregates tends to be the most vulnerable. So it's also good news that the work that's needed, the weakest points tend to be in basements and crawl spaces, and those tend to be the easiest to access. And it's a fairly limited scope of work. This is more Bill's area. We should be prepared in more ways than just retrofitting. You should have a plan for what you're going to do when an earthquake hits. You should build a kit. The old rule used to be 3 days, 3 ways. I think Bill's rule of 2 weeks is a much better standard. And then, getting involved in the communication hub or Seattle's program called SNAP, Seattle Neighborhoods Actively Prepare, or getting, certified as a rescue technician. Those are all ways to prepare and make it so that we can rely on one another. And when you put a kit together, there's a lot more than just food and water that needs to be in there. There are a lot of great resources on here, but things to think about are, shoes. They say you should have a pair of shoes upside down under your bed so that you can grab them quickly. And if a window breaks right next to your bed, they're not going to be full of glass, right? Seems pretty easy. If you have kids, diapers, feminine products, garbage bags to put all those in. These are things that may not think about, but they're really easy to put together and have prepared. So I'm not going to spend a lot of time on this, but there are great resources for this and a lot of good lists that you can just Google and put together a kit. It's also advisable, think about maybe putting a kit, a smaller version of your kit in your car. Because a lot of us, whether we're at work or visiting someone or at home, our car is usually nearby. So it's a good place to have some of our supplies. So of course, I'm a retrofit contractor. This is what I do. This is mostly what I'm going to talk about. And why do we want to protect our homes? Of course, it may be our biggest investment or one of them. A lot of us are motivated to do a retrofit because of earthquake insurance. It may be a requirement. Parents often want to keep their kids alive. That I can understand that. If you have either an accessory dwelling unit or a rental property, maintaining your income and doing the right thing and keeping a roof over your tenants' heads, both are good motivating factors. And then the last one, convenience. What I mean by convenience is the convenience of not having to repair, whether or not you have insurance, the convenience of not having to find a contractor and do a repair when contractors are impossible to find. The convenience of not having to find an emergency shelter or stay at a friend's house who was more prepared because your house has a red tag on it for the months and months that it's going to take until you can get it repaired. So that's what I mean by convenience. I think convenience is the most, sort of understated thing on this list. Now this slide, we're going to see this one twice. I want to focus on the left because this is how we know our wood framed homes perform. For the most part, our wood framed homes from the first floor framing, from the first floor joists up, they tend to stay together as a box. They weren't built with plywood shear walls, but there are a lot of walls there and they have lath and plaster, or they have sheetrock, or they have paneling, or they have something on them. And there are a lot of them, and they're at right angles to one another, and they just sort of buttress the main floor, the second floor of the home. So again, that's good news. We don't expect our wood framed homes to just collapse in a heap. They're not going to be a pile of lumber. They're going to try to shift as a box, sort of as all three of these pictures, the first floor and the second floor and the roof, all try to move as a unit. And the force is greatest and the walls are weakest at, below that first floor framing. And I say the force is greatest. The mathematical scientific equation is force equals mass times acceleration. So the acceleration is how much the earth is going to move, or how quickly it moves, more correctly. And that's going to be the same everywhere, right? The ground and the house and, the roof, the floor, those are all going to experience the same earthquake. But the parts lower in the house have more mass on them. They have more weight above them. So these basement walls have 3 times as much weight as, at the top of the walls, the connections that just support the roof. So they will have 3 times as much force. They will be 3 times as likely to fail. So that's why we focus on this part of the house, what we call the cripple wall above the foundation and below the first floor joists. And some homes don't have that. There's no cripple wall, but we still focus on that part of the house. So we'll come back to this slide, but that's how houses fail. And it's not just theoretical. While we in Seattle have not had destructive earthquakes, California has experienced them for us. Thank you very much. And we have gotten to look at how their homes performed and how they failed and where retrofitting really helped. And so that's where a lot of our technology comes from. And actually, before I get to the California homes, I want to talk about Turkey. So 2 weeks ago, there was a big earthquake in Turkey, and also affected a big portion of northern Syria. And obviously, even this number is out of date. Last I heard, it was closer to 50,000 people have been killed, and tens of thousands more are still missing. So it's a huge disaster. And almost all of the loss of life have come from buildings failing, buildings collapsing. And Turkey has, somewhat different earthquake risks. They're in between a number of big faults, and they're one of the most active areas in the whole world. And I will acknowledge that they have different construction. They have a lot of, multifamily apartment buildings made of concrete, which we don't. And concrete is less resilient. But here's what's the same, is that in Turkey, like here, we know how to make buildings safer. They know how to make buildings safer. There are codes, and new buildings are made safer, or are supposed to be. And a lot of the problem in Turkey, they're finding, is that buildings were not built to that code. They were allowed not to be built to that code. And I think the most generous assessment of that is that they knew that they had a housing crisis, and they were trying to get as many roofs over people's heads as quickly as possible. A more cynical assessment would be that there were some contractors with bad motives who were just trying to make as much money as possible, and some building officials and government officials who allowed it to happen because of corruption and greed as well. And so it's truly a tragedy. And here's a photo from Turkey. This is just in the last 2 weeks. And you can see that some of the buildings were reduced to absolute rubble. They pancaked, and they just came down one level after another, and they are nothing but rubble. There are no air pockets in there. But what's striking is that there are buildings in the background that look pretty much entirely intact. And what could the difference possibly be? Is it that the earthquake was more violent here than it was a block away? I don't think so. It's that some of these buildings were built to code with the elements built into them or added to them as part of a retrofit that we know makes homes safer, and some weren't. So it makes can and does make a difference. And you could probably hear the passion in my voice. I think this is a preventable tragedy. Now we're going to the California homes. These are older photos. You can see this one's black and white. This is, I think, Northridge in 94 or 95. And you can see, like my little line drawing from a couple of slides ago, that bottom layer sort of buckled. This one, right below the first floor framing, everything above it is intact. Everything below it buckled, and that house is like 2 feet over and 2 feet to the left of where it started. And this, it's a black and white photo, so you can't tell, but that's a red tag. That means that those homeowners are not allowed into the home. This one is another one. You can tell that it's red tagged, and the whole thing ended up about 4 feet over and 4 feet sort of away from us. And it looks kind of dramatic because this post didn't fail. And so as the house came down and the roof of the porch stayed up, it kind of caused that to look pretty dramatic. But look, the windows aren't even broken in that, right? The house stayed together. If that bottom layer had been strengthened, the house would have been perfectly usable. Here's another one. This went kind of over and to the left. That's the way it buckled. And there's another red tag on it. Here's another one. This one went down and to the right. You can see this door was supposed to be up at the porch level here. And again, a red tag. This one down and to the right. Can't see the red tag, but I'd be surprised if that one's legal to occupy at this point. And this one is actually one of my favorites because the house almost looks like nothing's wrong with it. It's just sitting there square as could be. Windows are unbroken. The door looks like you could just turn the knob and walk right in, except that front door is supposed to be up here at the top of the stairs. That house started, over here, and the whole thing is about 3 or 4 feet over and down to the left. So that line drawing that showed these 2-story houses, failing at that lowest level, that is exactly how they behave. That's not just an illustrator sort of taking liberties. This is what we know occurs. We know where the weak parts of our houses are, and we know actually how to protect them as well. All right, but the cynics out there will say, we don't know what the difference was between the buildings that survived in Turkey and the buildings that failed. It could be code, it could be something else. And you see houses that failed in California, but we don't know that that a retrofit would have saved them. So this is the closest thing I have to a controlled study, where in Japan, like here, their code has evolved. And so they actually built 2 houses, one the way, and these are full-size houses. You can't really tell, but these are, human beings up here on the balcony. So these are full-scale houses. And one was built to the old code, and one was built with plywood and connections between the levels as a retrofit would install. And they don't have basements, so you need to think of this first floor as sort of that cripple wall that we're going to be worried about in our homes. And then, sorry, what did they do? They put it on a shake table, and they actually, this is a table that will simulate the movement of an earthquake. And we're going to watch this. I'm going to watch the timer. They're kind of winding it up here at 21, 22 seconds. They let it go at 26 seconds. And at 33, at 33 seconds, the building on the right had completely failed, and the one on the left is still largely intact. It's not undamaged, but it's certainly survivable and most likely livable after an earthquake. And that's kind of our goal. First, we want to make the home survivable, make it so that you and your family can walk out of the house alive. And second, and I guess it's not quite as important as being alive, but we want to make it so that your home, you can walk back into it and actually shelter in your own home again instead of an emergency shelter. So this slide again, how do we prevent? Actually, I'm going to start with the middle one, because the first thing that's likely to fail, and we saw that in those photographs, is that cripple wall buckles. A lot of our homes, there's a 2 or 3 or 4 foot framed wall built on top of the foundation, and then the first floor joists are built on top of that. That is the Achilles heel of our homes if we have that construction. So that's the first thing that will fail. How do we prevent that failure? We brace it with plywood. We put shear panels on that wall, and that strengthens the wall to where it can resist the forces and stay intact. Once we've done that, it kind of brings into play 2 additional failure mechanisms, which are that the framing can then slide off the foundation. And so we want to anchor the framing to the foundation, or the joist can slide off of that cripple wall. And so we have hardware connectors that prevent that. So that's kind of the ABCs of retrofitting. It conveniently turns into actual little alliterative thing with ABC, anchor, brace, connect. So we're going to talk about those in order. Anchoring, a lot of people understand that retrofitting has to do with bolting houses to their foundations, and it does, but that's not all. So where there's room, the way we bolt is we actually drill straight down through the framing, drill into the concrete, and install bolts. Or what my company uses is we use these big concrete screws. There are other anchors that are a little easier to install and cheaper, but they're also weaker. So this is kind of my standard. But if you're familiar with concrete wedge anchors or wedge-alls, or epoxy anchors, those are also allowed. We just like these screw anchors because they're so much stronger. But you can see the size of our tools. This is an impact driver that we use to actually spin these screws into the concrete. The tool that we use to drill into the concrete is even taller than this. So we need a certain amount of room directly above where we're trying to fasten for these vertical bolts to work. Where we don't have room, and here's a house with no cripple wall at all, so obviously there's no room to drill vertically here above the sill plate. The alternative are these side anchor plates. And Simpson Strong Tie is the company that makes all of these, and they work with us retrofitters, and they've come up with hardware that fits our needs. This one in particular is designed because a lot of us have a 2x4 sill, which is 3.5 inches wide, sitting on a 6-inch concrete foundation. Of course, is 6 inches, that leaves 2.5 inches here. Well, this hardware is designed to sort of reach 2.5 inches and accommodate that setback. So that's the URFP, the Universal Retrofit Plate. Some homes, the framing is flush, or it can be made flush with a shim, in which case there's a flat retrofit plate, which you might be able to guess the code. That's FRFP, for flat retrofit plate. So that's anchoring. Another thing tied into anchoring is, mostly we're trying to prevent sliding of the framing on the foundation. But if we have tall walls, or if we have short lengths of walls, the geometry of those wall sections can actually cause them to try to kind of lift up at the corners. And that vertical overturning force, we resist differently. We've got these hold downs that, instead of just fastening to the sill, they fasten into the studs, or a built up post of many studs. And they anchor more deeply into the foundation in a way that resists withdrawal and uplift. So hold downs and anchor bolts or anchor plates would be the A part of the ABC. The B has to do with plywood bracing. There are a few other ways of doing it when we have to, but for the most part, the easiest way to stiffen walls is not diagonal braces, it's not steel frames, it's putting plywood on the wall. Plywood is so much stronger than the shiplap boards that most of our older homes have. But plywood is really effective if it's done right. There are just so many things that need to be right for it to be truly effective. It needs to be the right kind of plywood, structurally rated. Needs to be the right kind of nails, which are called shear nails, which are thicker wire nails than most. The nail spacing is critical. You can see a lot of nails around the perimeter of each plywood panel. Even here, where two pieces of plywood come together, for those to work as one shear panel, we actually need to double up the stud behind there. So there are two 2x4s that are nailed together. And those two 2x4s allow us to put this many nails into it without splintering the wood. The way we cut the plywood, we can't have any overcuts if there's an inside corner. That can cause a weak place for the plywood to start to tear when it's put under stress. So again, there are a lot of things to mess up, but if it's done right, shear panels are very, very effective at strengthening these cripple walls or pony walls. Those are cripple wall and pony wall are synonymous terms for this wall above the foundation and below the joists. I'm also going to mention a couple of things. This mentions ventilation holes. Most of our homes, that's not going to be what we use. Ventilation holes we only do if there's a cripple wall in a crawl space, an unheated space. Mostly we're going to insulate those stud bays instead. And then connect. We know that there's a weak connection where the joists rest on either the cripple wall or the sill plate that they're built on. So there's hardware and a couple other ways of making a very effective connection between the joists and what they rest on. If we do those three things, anchor, brace, connect, our homes are going to be much, much safer. The final two things are not really structural things, but we want to make sure that the water heater's strapped with straps that are made for water heaters and strapped to the framing, and that the space behind the water heater is filled if it's not right up against the foundation or the framing, so that it has no room to move. Another thing that most of our clients opt for is what's called a Northridge valve. It's an earthquake actuated shutoff at the gas meter. Senses motion, automatically shuts the gas off so that you can't have a gas fueled fire or an explosion. Here are some things that apply to retrofits. We always need a building permit, and that's in Seattle and Shoreline and every jurisdiction around here. There are two ways to get a building permit. We can always have a structural engineer design a retrofit and do the calculations and specify the bolt spacing. There is a project, PI stands for project impact. That's a prescriptively engineered plan that fits some homes. And so people wonder what the permit costs. If you're able to use that project impact plan, it's about $200. It's more like $500 if you're getting an engineered plan permitted. You could usually do that online. No longer need to go downtown to submit your applications. If, this is something to remember if you're doing it yourself, there are 2 inspections on most jobs. The inspectors need to be able to see those bolts and hold downs, and those are going to get covered with plywood, so they need to see them before we cover them. And then they need to inspect plywood in the way we've nailed it as well. So there are 2 inspections there. Engineering, again, most of our projects are engineered. We find that it's less than 20%, probably closer to 10% of our projects actually qualify for project impact. Now, there is a new, hot off the press, there's a new version of the prescriptively engineered retrofit plan. I was part of the committee that developed that, and my goal was to make it more usable, try to eliminate some of the obstacles that prevented homes from fitting that plan. So we'll see how well I did on that, but hopefully a few more homes that will actually qualify for the standard plan. Homes that don't, if you have a cinder block foundation, you always need engineering. We do have a way of retrofitting it, but it needs to be engineered. If you have any walls that are over 4 feet tall, any cripple walls, that used to be a deal breaker for project impact, not necessarily anymore. Let's see, the engineer doesn't always need to come out. My engineer works off of my notes and drawings. If you're hiring them yourself, expect, I think $400 to $1,000 is a pretty good range for the engineering portion itself. If you hire a contractor, just do your due diligence. We all check reviews anymore, maybe Better Business Bureau, but check L&I. You can go online and see what kind of a license they have and how long they've been in business, and if they have any complaints or fines, that is. You can also do the work yourself. It is not required that a contractor do a retrofit. If you're going to do it, please educate yourself. I have a longer version of a similar webinar on my website. The Seattle Emergency Management actually does these 2-hour classes where retrofit contractors will come and kind of talk you through it. Whether you're working with engineered or the standard plans, read every bit of it. The details matter. The general structural notes, the little notes next to every part of the details, the plan. Just make sure you really understand the requirements. if you're doing it yourself, you will still need a permit, and you're still likely to need engineering. And remember that first bolt inspection before you cover things, or you will be sorry. If you're doing it yourself, don't try to use your uncle's, hammer drill with a masonry bit. You will want a true roto hammer, an industrial grade roto hammer with a concrete bit. It will cut the time involved, by 1,000%. Even if you do it yourself, and even if you get a permit, that may not meet your insurance requirements, and you may need someone like me to write a letter for you to certify that the work is done. And just understand that it's going to take you, I like to say, a month of weekends to retrofit your home, where, if a professional crew comes in, we may be in and out in 2 or 3 days. And safety is important. There are legal requirements for contractors regarding lead paint and silica dust and asbestos. You're going to encounter the same things. A lot of our old basements have a lot of nasty junk in them, and you don't want to be breathing that. And silica dust is something that we can't help create. We're drilling into concrete, and that creates respirable silica, which is a carcinogen. Well, what we do is we have a fancy $15,000 system that has a HEPA vac and a filter cleaner and tools that have shrouds on them. So we're actually sucking the dust up before it ever becomes airborne, which generally keeps your house cleaner too, which is nice. And cleaner is safer, and cleaner is more efficient. So just cleanliness and especially sucking up the dust is really, really important. Okay, everybody always wants to know, yeah, but Leif, how long does it take and what does it cost? And they want to know how much per square foot. And I can't answer it that way, but I can say we have 3 general types of jobs. Either you have a crawl space, those tend to be the simplest. And those are, roughly $5,000 in a couple of days. An unfinished basement. By unfinished basement, I mean, I walk in there and I'm actually looking at the studs of the cripple wall and there's nothing on them. Those might be a $10,000 project and take a week or so, give or take. If you have a finished basement, a retrofit can still be done. It can be done from the inside or the outside or a combination. But of course, we need to remove the finishes before we can get to the framing and foundation and anchor those. So those end up being, expect a $20,000 project and 2 weeks. So those are kind of the main questions that people ask. And I just want to sum up and say that it works. I showed you the video. We know that it works. The guy that lent me all those photos from California, he was a FEMA inspector, and he said it was so clear which houses had been retrofitted and which ones weren't when he was doing the census after the Northridge earthquake. There was a house standing and looked perfectly intact, and a house just destroyed right next to it. And the only difference was that one had been retrofitted and one hadn't. So it works, but it has to be done right. I've seen a lot of sort of retrofits done by probably well-intentioned homeowners and contractors, but they just didn't have the information they needed. And I look at them and realize that those are likely to fail, and I almost need to tear everything out and start over. Let's see. So, if you're going to do it yourself, especially educate yourself. Just make sure that you really understand what you're doing and you're doing it right. If you're a contractor, educate yourself as well. I'm not at a home show, so you can't visit our booth, but I will ask if anybody has any questions, and I will invite you to unmute yourself and ask me a question, whether it's about retrofitting or your house specifically. I guess I covered everything, huh?
Well, it looks like Sharon has raised her hand.
Oh, Sharon,
Yeah.
what can
Yeah,
I
I have
answer
several
for?
questions.
Uh-huh.
Okay. So the first one is, if you do have a retrofit, what magnitude earthquake are you expected to survive fairly intact?
That is a great question. And here, I'm gonna stop the share and stop the commercial, and now hopefully you can see me in the gallery. But so the first thing I need to say is there are no guarantees. We're doing work that we know to be effective, but if you get a bid from me, the first thing you'll see is I can't guarantee that you won't have damage. I will say both the engineer and the standard plan are designed for, and they don't really talk about magnitude either, but they talk about this roughly 2,000-year earthquake, which is a big earthquake. That it means that the force that they're designing for, the lateral acceleration of something like 1.3 Gs, that is equivalent to a Seattle fault zone earthquake. It is equivalent to, or exceeds the force that we expect in a subduction zone earthquake. So, and I will say this, that engineers are really, really conservative creatures. So if that's what they're planning for, is this 2,000-year code level event, they're not going to have me or you build in just enough reinforcements to resist that. There's probably going to be a safety factor of about 3x sort of baked into the plan. So I think, that I feel comfortable that in the Seattle fault zone, you stand a much better chance. In the Cascadia subduction zone, your house will probably almost certainly be standing still.
So if you were to have an earthquake retrofit maybe 20 years ago, have the standards changed dramatically? Is there a need for follow-up? I had one, the city, there was a program. I've been in my house about 33 years. There was a program where grants were given. I didn't even have to pay for it. And I had an earthquake retrofit. I can't remember the year, but I don't know if they've done plywood or if there are new standards. What should I do? Is it time to have another inspection? Is there something you might add to a retrofit that was done a number of years ago?
Well, great question. I was actually, I remember that program. There weren't a lot of homes that got done under that program. I think there was only $100,000 and a maximum of $5,000 each. So like 20
Yeah,
homes
I
got
was
done.
lucky. Yeah.
So you're lucky, but during that time, we were operating on pretty much the same standards that we have now. So, and those retrofits were required to be permitted and inspected. So I would think you're probably in pretty good shape. Anything before 1999, there weren't really standards. And so it may be that what was done is doing something, but maybe bolts were put in, but not plywood. Maybe the plywood was put in, but it wasn't fastened right. And maybe those things can be upgraded or supplemented.
Is it worth having an inspection and an evaluation to see what standards I have and whether or not it needs bolstering in some way?
Again, just based on the fact that when you're describing the work happening, nothing has changed in any dramatic way. So a permitted retrofit in, the early 2000s,
Might have been before that.
I think you're good to go.
Thank you.
Yeah, and I do
Yeah.
see a couple of questions from Brian, so I may come back to you, Sharon, but I see Brian asked, are insurance premiums lower with retrofits? And have you identified homes that can't be retrofitted? So homes that can't be retrofitted, we get a few. I've had 2 homes on Queen Anne with brick, like a red brick, terracotta brick foundations, and those are tricky if the brick is very thin. There was one that was only 1 brick wide thick. It was, 1 stack of bricks forming this basement wall. And that one we couldn't retrofit. We actually had to pour a new foundation. But most homes, if there's a concrete foundation or even a cinder block foundation, we should be able to retrofit. And then the other condition, and I haven't seen this on Queen Anne, but on Magnolia, there occasionally I come across a home where the entire thing was built out of cinder blocks, not just the foundation, but the walls. Well, that's kind of beyond my beyond my pay grade as well. And then are insurance premiums lower with retrofits? Maybe. I find that insurance factors into a lot of the inquiries that I get. Sometimes people have contacted their insurer about earthquake coverage, and they've been told, we won't even insure you unless you get a retrofit. Some have been told that they get a discount. And so, I guess your mileage may vary. That's more of a question, Brian, for your insurer. But what you may find, even if your insurance company won't give you a discount, you may, once you have a retrofit done, you may qualify for other insurance companies, and you may be able to shop it and save money that way. I've got more questions in chat. Okay, if I just go to those. Susan says, Sound Seismic retrofitted your home in 2006. You've given me peace of mind and increased the appraisal value of my 1957 home. So thank you very much for that, Susan. That sounds great. I like hearing that. Sean asks, just clarifying, you only work on single family homes and not condos. For the most part, that's true. We do find a few condominiums that are built much like single family homes. They're wood framed and, basically built like large houses. And we have done a few retrofits of those. We have to have access to that sort of bottom level, bottom portion of the home. So either it needs to have a crawl space below it or a basement that's not, somebody's condo unit, so that we can actually get to everything. So Sean, if you'd like to, a more specific answer, send me an email with your address and I can look it up and see what I can tell. Any other questions? Sharon, you still have your hand up. Do you have more?
Hi, this is Louis. You mentioned inspections several times. Are those inspections kept by the city anywhere?
Yeah, so when we get a building permit, a few things happen. A building official reviews the plans and makes sure that the work that we're proposing is going to be effective. And then they send building inspectors out. We have to schedule those. And a record of all this, remains online. So really anybody can look up your address and see what permits have been pulled and what inspections were done. So that, if a permitted retrofit has been done, in the computer era here in the last 20 something years, there will be a record of it. And that remains, what we do if someone's trying to get earthquake insurance, we also provide a certificate, because I find that insurance, underwriters and insurance agents don't really want to, they don't want to look at photos. They don't want to look at the permit record. They want somebody to say, there are anchor bolts, there's plywood bracing, there are joist connectors, and the water heater is strapped. And so I have a form that's made so that even an insurance adjuster can understand it.
All right.
There are no insurance adjusters in the audience, are there?
Sorry, I was muted when you called on me at Sharon. I think you had something in your presentation about project. Was it impact? What is that, first of all?
Yeah, great question. So Project Impact, they're actually calling it something different now, but the idea was that before 1999, the city, they didn't require permits. They just kind of said, gosh, if you're doing a retrofit, you're making the house safer, we don't really care what you do, just do it.
Oh.
And then they realized that a lot of people were doing work that wasn't really effective, and they were sort of self-engineering stuff and doing a half-assed job. And so they came up with a set of standards back in '99, and kind of specified that the work is these ABCs below the first floor framing. And they started requiring a building permit. And since they were requiring this permit, and they realized that might be onerous for people, they came up with a prescriptive plan so that not everybody in theory would need a structural engineer to custom design their retrofit. And so it's prescriptively engineered. It's available online if you search for I think it's Seattle Earthquake Home Retrofit Plan Set, PLANSET, all in one word. I think that'll get you there. Again, for over 20 years, that 1999 version survived with virtually no modifications to it. And then 3 years ago during COVID, a group of us reworked it, and it has just now finally made it into use. And hopefully, like I said, fits more homes. But the idea is that, if you have a 2-story home and you have wood siding and it's so many square feet, it will tell you sort of how many anchor bolts, how many feet of shear wall you need on each side of the house. And it's not simple, but if done right, it should sort of save the cost and time of having an engineer design a retrofit.
Thank you. And are there any programs similar to the one I had? Are there any grants available these days for this project?
There are not. That was a one-time thing, and I get asked that from time to time, and I'm not aware of any grants or low interest loans or anything like that.
Thank you. Great presentation, by the way.
Thank you very much.
So this is Louis again. I recently bought a house, and the only thing I have are the pictures of the retrofit and the marks in the wall where they did the work. Do you advise me to keep researching it, or I should trust that everything was done right?
Louis, are you trying to get earthquake insurance, or are you just trying to sort of get peace of mind that you're safe?
Yes. Well, I was originally thinking that maybe I could get a break on the earthquake insurance, which I already have, but I'm not too optimistic on that. So it's more for my peace of mind, I guess.
Louis, I'll invite you to email me the photos that you have, and I'll take a quick look at them off the clock and give you my opinion and see if I think your house meets I'm familiar with insurance standards, and I can tell you if I think your house meets those standards or if more work is needed.
What did you say for me to email you?
You can just email me the photos. My email is Leif, my first name, Leif@soundseismic.com.
All right.
I'm gonna
I'll put that in chat right now.
I'm just putting it up here as well for the moment. And then I saw a question from Brian about posts and beams. So it came up in an inspection report that posts and beams be strapped, which is interesting because a lot of homeowners also ask me, or they take me down to their basement and they point at the big center beam running down the middle of the basement and the post that it sits on. They say, my house needs a retrofit. I need straps on that. That's actually not a required part of it. The idea is that it's lateral shaking that we worry about. And if we do a good job of keeping the perimeter of the floor platform from shifting relative to the foundation, then the middle can't go anywhere relative to the foundation. So it's not a required part. There shouldn't be any stress put on those connections, but it is pretty easy to just put some hardware connectors on there. Some T-straps or what are called post cap hardware, where the beams are supported by posts. That's really easy to do. They could be nailed on, they could be done by a homeowner. And then there are similar connections, post base hardware that's used for the bottom of the post where it sits on the foundation. And they don't hurt, while I believe the engineers that they shouldn't be needed, why not do them? We generally do. So I know I'm over time here, Paula. I want to be.
That's okay. If people have questions, now is the time to ask them. So we appreciate your taking time to do this evening. It's great for people to know what's involved and why it's important, because obviously, having a safe place to live and to be for you and your family is probably one of the biggest things that we don't think much about. We just assume our homes are safe, and they aren't always. So anyway, any other questions for Leif this evening? If not, his email is in the chat, and we will send a recording of this particular meeting to everybody who registered for the meeting this evening. So everybody who's attending now will get that link too. So it'll be a YouTube video, and I'll have to upload it. But anyway, so yeah. Any other questions before we wrap up this evening?
Paula and Bill, thank you very much for having me, and I want to thank everybody for their involvement in the questions. That made it more fun and interesting for me.
Absolutely. Thank you.
Thank you.
Thanks again.
Thanks, everyone. Okay. Good night. Thanks, Leif.
Right.
Thank you, Bill.